Have you ever wondered how those massive, long-framed machines sculpt a perfectly flat road or a pristine slope on the side of a highway? From a distance, it looks simple. It looks like a giant yellow tractor just dragging a piece of steel through the mud. But if you've ever tried to smooth out a gravel driveway with a rake, you know that making the earth perfectly level is actually one of the hardest things to do in the physical world. In the industry, we call the motor grader the grandmaster of heavy equipment. And today, we're going to look at the brutal physics that allow this machine to carve perfect slopes out of raw earth. It's a fascinating dance between blade geometry, hydraulic wizardry, and the kind of operator skill that takes a lifetime to master. We're going deep into the hidden science of how these machines defy gravity and friction to transform jagged terrain into a work of engineered art. To understand why a grader is so special, you first have to understand the problem it's trying to solve. Dirt is stubborn. It's heavy, it's full of friction, and it wants to stay exactly where it is. If you use a bulldozer to level a road, the dozer is constantly bouncing over the very bumps it's trying to flatten. Because a bulldozer has a short wheelbase, every time the tracks go over a rock, the blade dips or rises, creating a washboard effect. But look at a motor grader. It's stretched out. It has that incredibly long frame with the blade tucked right in the middle. This is the first law of grader physics. The longer the wheelbase, the smoother the cut. When the front wheels of a grader hit a 6-inch bump, the blade in the center only moves a fraction of that distance. The machine essentially bridges the imperfections of the earth, allowing it to shave off high spots and fill in low spots with millimeter precision. It's the same reason a long bed truck rides smoother than a short wheelbase Jeep, but in the dirt world, that stability is what allows for final grade. Now let's talk about the business end of the machine, the blade, or what we call the moldboard. This isn't just a flat piece of steel. If it were flat, the dirt would just pile up in front of it until the machine lost traction and stopped. The moldboard is curved for a very specific scientific reason. It's designed to create a rolling action. As the blade cuts into the soil, the curve forces the dirt to curl forward and roll like a wave in the ocean. This soil flow reduces the friction against the blade, which means the machine can move more material with less horsepower. But the real magic happens when the operator angles the blade. This introduces shear force. By angling the blade, the operator isn't just pushing dirt forward, they're side casting it. The dirt moves along the length of the blade and falls off the heel, creating a neat pile called a windrow. This is how a grader creates a slope. By tilting the blade so that the toe is deeper than the heel, the operator is literally carving a 3D incline into the earth. They are fighting the lateral drift of the machine while forcing the soil to obey the laws of geometry. To hold that blade perfectly steady while cutting through hard-packed clay or frozen gravel requires an incredible amount of force. This is where the hydraulic Maestro comes in. Inside the cab of a modern grader, the operator is managing a forest of levers, sometimes up to 10 or 12 of them. Each lever controls a different hydraulic circuit. You have the lift cylinders that move the blade up and down, the side shift that slides the blade left or right, and the power tilt that changes the pitch of the blade. Think about the physics here. If you're carving a 2-to-1 slope on a steep embankment, gravity wants to pull the entire machine down the hill. To counter this, graders have a unique feature called wheel lean. The operator can actually tilt the front wheels into the slope, like a downhill skier leaning into a turn. This uses the weight of the machine to fight the side draft of the blade. It's a constant battle of vectors. The machine wants to go one way, the dirt wants to push it another way, and the operator uses hydraulics to find the perfect equilibrium in the middle. And speaking of the operator, this is where the human element becomes the most important part of the machine. You can have the best hydraulics in the world, but if you don't have an operator who can read the dirt, you're just making a mess.
The best grader operators in America are often the oldest guys on the job site. Why? Because grading is a feel sport. When you're sitting in that cab, you aren't just looking at the blade, you're feeling the vibration of the engine and the tension in the frame through the seat of your pants. An experienced operator can tell if the soil is too wet, too dry, or if they've hit a pocket of sand just by the way the steering wheel vibrates. They have to coordinate their hands and feet in a multi-axis dance. While they're steering with one hand, the other hand is constantly feathering the lift levers to keep the grade perfect. They're looking at the toe of the blade to make sure they're cutting deep enough, and they're looking at the heel to see where the dirt is going. It's like trying to play a piano while driving a bus through a rock slide. In the old days, this was all done by eye. An operator would look at blue tops, wooden stakes driven into the ground by surveyors, and they'd have to guess the grade. But today, the physics have gone digital. Modern graders are often equipped with GPS and 3D grade control. The engineering plans for the entire road are loaded into the machine's computer. Sensors on the blade track its position relative to satellites in space. If the operator is off by even 1/8 of an inch, the computer can automatically adjust the hydraulic valves to bring the blade back to the perfect elevation. This has revolutionized the industry. It means we can build roads faster and with less waste. But even with all that tech, the brutal physics don't change. The GPS can tell the blade where to go, but it can't tell the operator how to handle a patch of pumping mud or a hidden boulder. The machine still has to fight friction, weight, and gravity. The technology just gives the Maestro a better baton. Of course, the environment doesn't always cooperate. Rain is the enemy of the grader. If the soil gets too much moisture, it loses its structural integrity. Instead of rolling off the blade, it turns into a sticky mess that clings to the steel. On the flip side, if the ground is too dry, it turns to dust and blows away, making it impossible to achieve a hard pack finish. This is why you'll often see a water truck following the grader. The operator needs just the right amount of moisture to create compaction. They're not just smoothing the surface, they're knitting the soil particles together. By using the weight of the machine and the pressure of the blade, they're creating a foundation that can support the weight of thousands of cars. As we look to the future, the grader is evolving. We're seeing more automation, more AI-powered sensors, and even some fully autonomous machines in controlled environments like mines. But the core design of the motor grader hasn't changed much in 50 years. Why? Because he can't argue with physics. The long wheelbase, the mid-mount blade, and the articulated frame are the only way to solve the smoothing problem. Whether it's a dirt track in rural Iowa or a massive multi-level interchange in Los Angeles, the grader is the machine that puts the final in final grade. It is the bridge between a rough pile of dirt and a perfectly engineered surface. So, the next time you're driving down a perfectly smooth highway and you don't feel a single bump or dip, take a second to think about the grader. Think about the Maestro in the cab, fighting the friction of the earth and the pull of gravity. Think about the brutal physics of that curved blade rolling a wave of soil into a perfect crown. It's easy to admire a skyscraper or a massive bridge, but the true foundation of our modern world is the ground beneath our feet. And that ground was put there millimeter by the most precise, most difficult, and most impressive machine on the job site, the motor grader, the grandmaster of the dirt. If you've ever spent time in the seat of one of these legends, or if you've ever watched a pro work and been blown away by the precision, drop a comment below. We want to hear your stories from the cab. What's the toughest slope you've ever had to cut? And if you enjoyed this deep dive into the engineering and the physics that build our world, make sure you hit that subscribe button. We've got plenty more stories to tell about the iron and the people that move the earth. Thanks for hanging out with us, and we'll see you on the next one.